Alright, so here's our first example. We're going to evaluate, let's write that, evaluate theta equals 5 pi over 6. We just did this as our warm-up problem. So we basically said that this is essentially 0 pi over 6. This is 3 pi over 6 because that reduces to pi over 2. This is 6 pi over 6, which reduces to pi. And this is 9 pi over 6, which reduces to 3 pi over 2. And this is 12 pi over 6. And then using yesterday's lesson, reference angles, this is in quadrant 2. So if I come over here to quadrant 2, so to review yesterday's lesson, theta, this is 5 pi over 6. And then we said inside the triangle, theta prime is equal to what? Pi over 6, right? Okay, so here's our triangle. Okay, this is the next step after, so this was yesterday's lesson, right? Here is the next step now of using the special right triangles, or basically they call it evaluating. I need to make sense of pi over 6. You could use the formula, or just watch my rational thinking. If a whole circle is 2 pi, half of a circle is 180 degrees. In radians, that would just be pi. Okay? So watch this. 180 divided by 6 is what? 30. Now, if I come over here to my special right triangles now, I can fill out my triangle based off this information, okay? Always across the 30 will be a 1x, so I want you to write 1. Everyone say 1. And then over here, I want you to, okay, this is the 30, this is the 90, so always across the 90 you're going to write what? A 2. And then the third side, this is really a 60-degree angle, so always across the 60, you're going to write what? X radical 3, or the radical 3 side. And then from here, you can find your 6 trig functions. Someone shout out their favorite trig function. Someone said sine. So sine, now remember, when I'm evaluating here, sine at pi over 6 now, I'm just starting here at the green. That would be the opposite over the hypotenuse, or this would essentially be the y over r, which would be 1/2. There's a mistake on my picture. Put your finger on it. You should have your finger here. It should be what class? It's going to the left, right? So x values going to the left are negative. Someone said tangent was their favorite trig function? Okay, tangent is which 2 letters? Y over x. Zoom in for you. Okay, it's y over x. So what numbers? 1 over negative radical 3. And if I multiply by radical 3, this will give us negative radical 3 over 3. So tangent at pi over 6 is negative pi over 3. Negative radical 3 over 3. Someone else give me their favorite trig function? Cosine. Which 2 letters, class? Oh man, get those flashcards, guys. So x over r would be what? Over 2. Alright, give me your other favorite trig functions. Cotangent? cotangent at pi over 6 is what? What letters? X over y. So that would be what? Negative radical 3 over 1, which is just negative radical 3. And then, what's the reciprocal of cosine? Secant. And then secant is which letters? R over x. Okay, this is not going to be fun. So I have 2 over negative radical 3. You're going to rationalize. Here you don't have to multiply by the negative. So it's just radical 3 over 3. That is going to be negative 2 radical 3 over 3. And the last one is cosecant, which is going to be what? R over y, which is going to be 2 over 1, which is just 2. Let's summarize what we just did. I gave you theta is 5 pi over 6. And I recognize, can you guys go back and just add a 5 here? Add a 5. So essentially what you did is you evaluated the 6 trig functions at 5 pi over 6. But class, do we draw our triangle over here in the blue? No, we have to make the bow tie, which is the pink. And yesterday's lesson we found the reference angle. The reference angle is pi over 6. To help us use our special right triangles, you could convert to degrees. I eventually want to get very comfortable that pi over 6 is essentially the same thing as 30 degrees. And then you label it based off your special right triangles. Always across the 30 is a 1, always across the 90 is a 2, and always across the 60 is negative radical 3. And in some ways, guys, instead of memorizing the unit circle, you can actually derive it. This might look like a lot of work, but this is actually, you don't have to memorize anything. You can just do the math.